In this video, we are going to learn how to simplify series and parallel combination of capacitor circuits. You know already the capacitor connected in series and parallel, and there is a lump of capacitors. We need to simplify and get the effective value, equivalent value of capacitance. In today's video, I am going to solve some few problems, and I am going to teach you how to simplify the circuits involving series and parallel arrangement of capacitors. In this video, I have solved some 7 peculiar and basic problems to make you understand how to simplify any circuits. If you solve these 7 problems, you will be able to solve any other complicated circuits. So let's learn how to simplify the series and parallel combination of capacitors. Question number 1. 3 capacitors of 2 microfarad, 3 microfarad and 6 microfarad connected in series. Find equivalent capacitance. Solution. First of all, we need to draw a rough diagram, circuit diagram, in which 3 capacitors shown in series combination. So this is the first capacitor. They are connected in series. So we got 3 capacitors and they are connected across some supply and a key. So this is a circuit diagram. Call them as a C1, call them as a C2, call them as a C3. They are connected in series combination, where C1 is 2 microfarad and C2 3 microfarad and C3 is 6 microfarad. They are connected in series combination. Let CS is equivalent capacitance of series combination. Formula is 1 upon CS equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This is equivalent to C2 C3 plus C1 C3 plus C1 C2 upon C1 C2 C3, or we can say CS equals to C1 C2 C3 divided by C1 C2 plus C2 C3 plus C3 C1. So when 3 capacitors connected in series combination, the shortcut formula becomes CS equals to C1 into C2 into C3 upon C1 C2 plus C2 C3 plus C3 C1. Now putting the values of C1, C2 and C3. C1 is 2 microfarad, C3 is a 3 microfarad and C3 is a 6 microfarad upon C1, C2, that is a 2 into 3 plus C2, C3, that is 3 into 6 plus C3, C1, that is 6 into 2. This is equals to, keep the numerator as it is. Don't waste your time in multiplying. First see what is the denominator. So we get here the 6 plus 18 plus 12. So CS equals to 2 into 3 into 6 upon 20, 30, 36. Now C cancellation. 6 1s are 6 6s are 2 3s are and 3 3 also get cancelled. Therefore CS equals to 1 microfarad. Therefore equivalent capacitance equivalent capacitance of series combination CS equals to 1 microfarad. This is required solution. Example 2, 3 capacitors 4 microfarad, 2 microfarad and 6 microfarad connected in parallel. Find equivalent capacitance. Solution. First of all, we draw the diagram. They are in parallel. This is the first capacitor, this is second capacitor and this is third capacitor. They are connected in parallel. So make a point here, then make a point here, then join all the starting point at one point and all end point at the other point. This is the parallel combination. And this is C1, it is a C2 and here is a C3. Let us call this as a point A and call it as a point B. So between point A and B, there are the 3 capacitors connected in parallel. So whenever the 2 or more capacitor connected in parallel, then equivalent capacitance that can be denoted by Cp or Ceq. That is the Eq stand for equivalent or Cp stand for equivalent capacitance in parallel combination. Let us use Cp. So Cp, whenever the 3 capacitors connected in parallel, their equivalent capacitance is given by C1 plus C2 plus C3. Therefore, Cp equals to, what is the C1 value? That is a 4 microfarad and C2 equals to 2 microfarad and C3 equals to 6 microfarad. Therefore, Cp equals to 4 plus 2 plus 6 equals to 12 microfarad. This is equivalent capacitance of this parallel combination. Example 3. Find equivalent capacitance of combination where C1 equals to 2 microfarad and C2 equals to 3 microfarad. Solution. We do observe that C1 and C2 are in parallel. Here also C1 and C2 are in parallel. Here also C1 and C2 are parallel. And in the fourth part, the C1, C2, even they are in parallel. So first we will solve these 4 parts and simplify the circuit. Since C1 and C2, these are in parallel, therefore Cp1 equals to C1 plus C2. Similarly, C1, C2 here are the parallel, therefore Cp2 equals to C1 plus C2. And in this third part, even they are in parallel, therefore Cp3 equals to C1 plus C2, and here also they are parallel, therefore it becomes Cp4 equals to C1 plus C2. Now we draw the simplified circuit diagram. So simplified circuit diagram becomes, here is a Cp1 and here is a Cp2. Here is a X and here is a Y. After here down, again Cp3 and here is a Cp4. After this, we need to further simplify the diagram. We do observe that Cp1 and Cp2 are in series combination and Cp3 and Cp4 are in series combination. Now Cp1 and Cp2 are in series combination. Call the result as a CS1. Similarly, Cp3 and Cp4 are in series combination. Call it as a CS2. Therefore, 1 upon CS1 equals to 1 upon Cp1 plus 1 upon Cp2. Cp1 is nothing but C1 plus C2. Cp2 nothing but C1 plus C2. Cp3 nothing but C1 plus C2. Even Cp4 is equals to C1 plus C2. Therefore, 1 upon Cs1 equals to 1 upon C1 plus C2 plus 1 upon C1 plus C2. 1 upon Cs1 equals to 1 plus 1 upon C1 plus C2 implies Cs1 equals to C1 plus C2 upon 2. Similarly, Cs2 becomes C1 plus C2 upon 2. After this, the circuit gets further simplified. So simplified circuit becomes, here is a Cs1 and here is a Cs2. XY and Cs1 and Cs2 are in parallel combination. Therefore, Cp5, that is a parallel combination of Cs1 and Cs2, is given by Cs1 plus Cs2, that is equals to C1 plus C2 upon 2 plus C1 plus C2 upon 2. Therefore, Cp5 is nothing but equivalent capacitance. Equivalent capacitance. Let us just call it as a Ceq. So Ceq is nothing but 2 into C1 plus C2 upon 2. 2 to get cancelled. That is equals to C1 plus C2. But C1 is nothing but 2 microfarad and C3 is a 3 microfarad. C1 is a 2 microfarad and C2 is a 3 microfarad. Therefore, equivalent capacitance becomes 2 plus 3 equals to 5 microfarads. This is required solution. Example 4. Find equivalent capacitance if each capacitor has value of 3 microfarad. So there are the 4 loops and in each loop there are the 2 capacitors and every 2 capacitors are in parallel combination. C1 and C2 are in parallel, C3 and C4 are in parallel, C5 and 6 are parallel, C7 and C8 are in parallel. So the parallel combination of C1, C2, that is a Cp1, is equals to C1 plus C2, and the parallel combination of C3 and C4, that is Cp2, Cp2 equals to C3 plus C4. Similarly, Cp3 equals to C5 plus C6. Similarly, C7 and C8 is nothing but they are in parallel. Therefore, Cp4 equals to C7 plus C8. Now, the circuit diagram becomes like this. First capacitor, second, third and fourth, and this is nothing but Cp1 and this is Cp2, this is Cp3 and this is Cp4. Now they are in series combination. Cp1, Cp2, Cp3 and Cp4 are in series combination. But every capacitor has value of 3 microfarad. Therefore, Cp1 equals to 3 plus 3 equals to 6 microfarad. Similarly, Cp2 equals to 6 microfarad. Similarly, Cp3 is equals to microfarad. Cp4 equals to 6 microfarad. Therefore, Cp1, this is a 6 microfarad. This is 6 microfarad. This is also equals to 6 microfarad, and this is also equals to 6 microfarad. Now these four capacitors are in series combination. Now we need to find their equivalent capacitance. Since the four capacitors are in series combination, so 1 upon C, that is a C equivalent, equals to 1 upon 6 plus 1 upon 6 plus 1 upon 6 plus 1 upon 6. Why? Because 1 upon C equivalent equals to 1 upon Cp1 plus 1 upon Cp2 plus 1 upon Cp3 and plus 1 upon Cp4. Therefore, C equivalent equals to 1 upon 6 plus 1 upon 6 plus 1 upon 6 and 1 upon 6. Now, we need to solve this. So, this is equals to 1 upon C equivalent equals to 1 plus 1 plus 1 plus 1 upon 6 equals to 4 upon 6. Therefore, C equivalent nothing but CAB, that is the capacitance between the point A and B, that is equals to 6 upon 4, that is 1.5 microfarad. This way we can solve. So CAB equals to 1.56 microfarad. So CAB, we were asked to find the CAB. So CAB, we got here 1.5 microfarad. This is what the final answer is. Example 5, find equivalent capacitance between A and B if each capacitor has capacitance of 10 microfarad. Here I have redrawn the circuit between the points A and B. C1 and C2 are in parallel, C3 and C4 are in parallel. So first of all, we find out their parallel combinations. The parallel combination of C1 and C2 is nothing but Cp1, that is equals to C1 plus C2, and parallel combination of C3 and C4, that is nothing but Cp2 equals to C3 plus C4. Therefore, equivalent circuit becomes, this is Cp1 and this is Cp2, and this is the point A and point B. But each capacitor has a capacitance value of 10 microfarad. Therefore, Cp1 equals to C1 plus C2, that is 10 plus 10 equals to 20 microfarad. Similarly, Cp2, that is C3 plus C4, each capacitor value 10 microfarad. Therefore, 10 plus 10 equals to 20 microfarad. Therefore, the circuit values becomes, here is a 20 microfarad, here is also 20 microfarad between the point A and B. They are in the series combination. Therefore, 1 upon CAB equals to 1 upon Cp1 plus 1 upon Cp2, that is equals to 1 upon 20 plus 1 upon 20. Therefore, 1 upon CAB equals to 1 plus 1 upon 20, that is a 2 upon 20. Therefore, CAB equals to 20 upon 2 equals to 10 microfarad. Therefore, in this circuit, the equivalent capacitance between the points A and B, that is nothing but CAB, equals to 10 microfarad. Example 6, find equivalent capacitance between the points X and Y if each capacitance has the value of C. So we got here the point A, point B, point C and point D. After D, there is another capacitor. So how to decide series and parallel? For that, you draw the A here, B here, and C here, then D here. And after D, there is one more capacitor. So this is C4. Now A to B, there is one capacitor. And from B to C, there is another capacitor. A to B, C1, and B to C, there is another capacitor C2, and C to D, there is one more capacitor. This is the D. This is the D. From C to D, there is one more capacitor, that is a C3. Now A and C are connected together like this, and B to D, there is one connection. B to D, there is one connection like this. This is called jumping. So implies that C1, C2 and C3 are in parallel combination. The reason is that there is a division of charge. So C1, C2 and C3 are in parallel combination. So first of all, we find out the parallel combination of C1, C2 and C3. That is CP1 is equals to C1 plus C2 plus C3. This value is equals to each capacitor value C, therefore C plus C plus C, that is equals to 3C. Now after the D, up to the D, after the D to Y, the circuit becomes like this. This is the CP1 and after that C4. Now they are in series combination. Therefore 1 upon CS1, that is nothing but 1 upon C of XY, that is the equivalent capacitance, is equals to 1 upon CP1 plus 1 upon C4, that is equals to 1 upon 3C plus 1 upon C. Therefore 1 upon CXY equals to 1 plus 3 upon 3C equals to 4 upon 3C. Therefore the final result CXY equals to 3C upon 4. This is required solution. Example 7. Find equivalent capacitance of combination of capacitors between points A and B as shown in the figure. So we got so many capacitors. First of all, let us name them. So C1 equals to 20 microfarad, C2 40 microfarad, C3 40 microfarad, and even C14 is 40 microfarad, and C5 and C6 each equals to 10 microfarads. Now we need to find equivalent capacitance of the combination. Step number 1, C2, C3 and C4, they are in series combination. Therefore 1 upon CS1 equals to 1 upon C2 plus 1 upon C3 plus 1 upon C4, that is equals to 1 upon 40 plus 1 upon 40 plus 1 upon 40, that is equals to 3 upon 40. Therefore CS1 equals to 40 upon 3. Now C5 and C6, they are in parallel combination. So we need to find their equivalent capacitance. And after finding out CS1, the diagram is modified this way. C5 and C6 are in parallel combination. Now we'll find out their equivalent capacitance. Therefore CP1 equals to Cp5 plus Cp6, that is equals to 10 plus 10. Therefore, Cp1 equals to 20 microfarad. Now we will redraw the diagram once again. Here is a and this is 20 microfarad, and after that here the equivalent capacitance, that is nothing but Cp1, and this is nothing but Cs1, that is a 40 upon 3 microfarad, and here is the B, and Cp1 equals to 20 microfarads. Now Cp1 and Cs1 are in parallel. Therefore, Cp2 equals to Cp1 plus Cs1, that is equals to 20 plus 40 upon 3, that is equals to 60 plus 40 upon 3 equals to 100 upon 3. Now the circuit diagram further modified. So let us draw the new diagram. So finally we get the C1 and Cp2, they are in series combination. Therefore Cs2 equals to 1 upon Cs2 equals to 1 upon C1 plus 1 upon Cp2, that is equals to 1 upon 20 plus 1 upon 100 divided by 3, that is equals to 1 upon 20 plus 3 upon 100. So that is equals to 5 plus 3 upon 100. So 1 upon Cs2. Therefore Cs2 equals to 100 divided by 8. Therefore Cs2 equals to 100 divided by 8. That is 8 ones are 2, 8 twos are then 12.5 microfarad. Cs2 equals to 12.5 microfarad. Therefore, equivalent capacitance of this circuit, that is a CAB, equals to 12.5 microfarads. So how did you find this video? Please write down your comments in the comments box. The next topic will be continuation of this topic. I will be solving more problems related to capacitors. So don't forget to subscribe the channels so that you and me are in regular touch with each other. So meet you with next video. Till then, wish you good luck. All the best. Please like, share and subscribe the channel. Okay, bye bye.